Hello class, today we're on lesson number 5 of chapter 9. We're going to do more on multiplying polynomials, okay? And we have here multiplying two numbers. When multiplying two numbers in arithmetic, we have this little illustration up here. The student is multiplying 2 times 2, and he's actually using a little calculator there. That's what it appears, at least to me. Now, when multiplying two numbers in arithmetic, we usually write but one below the other. It is also possible, however, to write them in a row. Now, consider, for example, the problem 15 times 48. Okay, writing 15 and 48 as the sums of 10 and 5, or 10 plus 5 and 50 plus 8, and illustrating the problem with the diagram showing area, we get the figure to the left. So I already have our figures here. Actually, I'm going to remove the one on the bottom. We'll draw that one up later. Let's get our pen. And let's go ahead and start writing. So we have 10. Oop, not thick enough. So we have 10 plus 5. And then we have 40 plus 8. Okay, now we would multiply 10 times 40 and we would have 400. We would multiply 10 times 8, that would give us 80. We would multiply 5 times 40, that would give us 200. And then 5 times 8 would be 40. Okay, and then we would add all these up, right? Now, how we would have done this in a row would have been 10 plus 5 times 40 plus 8. And this is an excellent way to illustrate how we use this method, particularly when we're dealing with variables, because we could add these two together and simply multiply them, right? But when we have variables, we cannot add, say, x plus 5 as we're going to have in our next example. We don't know what x is. So we have to state them as two separate terms. So the method that we would use would be as such, where we would multiply the same as we did 10 times 40. We did that over here, right? And we got 400, right? So we did 10 times 40, and that would be 400. Now they're actually showing you 10 times 10 times 40. I'm sorry, I might have said 80. 10 times 40 to give us 400. The next thing we multiplied over here was 10 times 8. Okay, so we went all the way across and went on to this side. All right, so plus 10 times 8, and that would be 80. Then we multiplied the 5 times 40, okay, and that would be 200. And then we multiplied the 5 times the 8, and that would be 40. So then we would add these all up, and that would be our answer. Now, there is a term that we don't have in this book, but we use in math. This is called the FOIL method. Okay. You might say, well, what do you mean by FOIL? Okay. Let's take the word FOIL. In fact, I'm going to write it this way. F-O-I-L. So you can see it's an acronym. And so what does F stand for? Well, F stands for, we're going to multiply the first terms, the 10 and the 40, right? So that would be the first terms. Okay. Then we multiplied the outer terms, the 10 and the 8 we multiplied. So those are the outer terms. Now if you figured those are the outer terms, then what is 5 and 40? Those are the inner terms. Okay. And so what would be the L? Well, this was the first. These are the last. 5 times 8 would be the last terms. Okay. So that's a little acronym that we use. Now, if we had more than 2 terms in each of these, then you certainly wouldn't be able to use the term FOIL. This particularly deals with binomials. We have 2 monomials represented together in this polynomial. We call them binomial as 2. We'll learn more about that in our next lesson. But nonetheless, we have first, outer, inner, last, and that would be the word FOIL. Okay. So using the FOIL method, let me just pause and clear up my board here. Okay, so we've cleared up our board. Let's now work on the next problem, or at least the next example. They have x plus 5 and 2x plus 6. So we're going to just write it out. X plus 5 and 2x plus 6. Now, if we were to put them in our illustration, we would have the x and the 5, and we'd have the 2x and the 6. Okay. Now it's very important. First off, these are all positive. There were no negatives. And secondly, you know, we don't have to. I could have put 2x and 6 here and the x plus 5. We just want to kind of reiterate that over and over. It doesn't mean, you know, you don't want to sit there and say, well, which one goes first? It doesn't matter as long as you. I think most importantly is that you do keep the expression on one side. So we have x and 5 here, and we have 2x plus 6. Now, if we were to multiply these, what would we have? Well, we would have 2x times x would be 2x squared. Now, before we move on here, let's go over to this side and do our first, outer, inner, last. We have x times 2x, so we'd have 2x squared. Okay, so we did our first. Now we do the outer, so it'll be x times 6, right? So we're going to come all the way over here, and we have x times 6. So we have 6x. It's positive, so we just add plus 6x. Now we're going to do, well, that's the outer. We're going to do the inner. 5 times 2x. So 5 times 2x would give us 10x. And then we'll write it down over here as we're writing. And then we do the last. The last would be 5 times 6. So let's just show you that over here. 5 times 6. That will be 30. And again, we have 5 times 6. So we did them in the same order, and you can see it's basically what we're doing, but we're doing them across in a row. Now you might say, but we're not done yet, and you're right. We have like terms, okay? Typically when you have these types of binomials where they're the same, the same degree, this is 2x to the first, obviously, and this is x to the first. And again, these are also the same degree. These two boxes will always have some math left over for you. Okay, and I just noted that because if this was 2x squared and this were 6x, it would change things up. Okay. Now let's go ahead and add up over here. 2x squared. And we have 6x plus 10x, that's 16x. And then we have 30. So we've now multiplied, and this is the expression, the polynomial. That's our answer. Now, if we keep reading, in these examples, we're multiplying polynomials by exactly the same method we used in lesson 4. The only difference is in the way everything is written down. Instead of writing one polynomial below the other and doing the multiplication as we would in arithmetic, we would write them everything in rows. The principle either way is the same. To multiply two polynomials, multiply each term of one polynomial by each term of the other polynomial, and then add the terms produced. So you just have to make sure you multiply them each. And I just want to come back to that negative term. We're going to have that in our first example here. Just remember viewing when you have a subtraction going on, that negative is applicable to the term to the right. Okay, so in our first example here, we're going to actually have a binomial, which is 2, but then we have what's called a trinomial. There are 3. So FOIL doesn't necessarily work for us here. Okay, let me clear up my board. Okay, let's get to example number 1. We're going to multiply 2x plus 7. So we have 2x plus 7, and we have, put that in parentheses, and then we have x squared minus 3x plus 2. Okay, so let's take a look. We have the box there. We have, I'm going to draw my box here. I like to keep the box. It's going to be important for you to learn how not to multiply, not how to multiply, but how to not depend on the box. Ultimately, when you start getting deeper into math, you're not going to be dependent on these boxes. I like the box right now because we're going to build off of this box in terms of factoring. So that's why you will see me using the box and they're using it. And as I said, I want you to sort of feel comfortable with where things lay out within the box because it will help you for factoring. But down the road, when you're doing your Algebra 2, you're not going to be using these boxes. You'll just get very familiar with just multiplying across, as we're doing here, this particular method that we're talking about. Now, FOIL does not work here because we have more than 4, F-O-I-L. In fact, we're going to multiply 6. We could see that in the box over here already. Okay, so let's go ahead and put 2x plus 7. That would naturally go here since they're 2. And then we would put x squared, we would put negative 3x, and then positive 2 here. Okay, so if we were to follow the method and we could see the green arrows that they draw, we would have 2x times x squared, and we have that over here. And what do we have? We have 2x to the third power. So I'm going to put equals here. I guess I can go all the way across. So we have 2x to the third power. Or, you know, they're illustrating it 2x times x squared, and they're just doing it to show you what they're multiplying, but we're just going to jump right into the second row where it shows 2x squared. Now the next thing would be 2x and negative 3x. That would be negative 6x squared. So I would have a negative 6x squared, or as we were writing, it would be minus 6x squared. Then 2x times 2, that would be 4x. Okay, so that would be plus 4x. Then we would have 7 times x squared, which would be 7x squared. And that's positive, so plus 7x squared. Then we have 7 times negative 3x, that will be negative 21x. And so minus 21x, or negative 21x. And then lastly, 7 times 2 would be 14. So we would have plus 14, it's positive. So we have now 6 terms. We have, let's make this 3 look like a 3 here. That's better. 2x cubed. We have a negative 6x squared. We have a positive 4x, a positive 7x squared, a negative 21x, and a positive 14. Now, when we get to this, we should note that we do have still some math to do here. We can combine like terms, and we have, when we're looking at it across here, you'll notice it this way. Okay, they're like this. Okay, but up here, you kind of have to go across and just go down the row and make sure that you get them all. So 2x cubed, are there any more? No. So we're just going to sort of go down here. We should probably just put the equal here and go all the way down and say, well, we have 2x cubed. We don't have any like terms there. Now I have a negative 6x squared. Do I have another x squared? I do have one, a positive 7x squared. So when I combine negative 6x squared and positive 7x squared, that's going to give me positive x squared. And now let's keep going down. We have 4x, positive 4x, go all the way down. Oh, I have a negative 21x. So when I combine those two, that will give me negative 17x. And lastly, well, we've done this, we've done that, we've done this, we've already added that, and we've added that, so we have positive 14. Okay, so now we have our answer as 2x cubed plus x squared minus 17x plus 14. Okay. We have a few more examples here. I'm not going to do them on the video. I think they're pretty much self-explanatory. What they're doing here is they're doing two, well, we have a binomial here and they're both negative. So you have to be very careful with your negatives. Make sure you're multiplying. In this case, we have a negative 7 and we have a negative 1. And notice they've gotten rid of the box. You can use the box. Again, I'd like you to be comfortable with that box. But the exercise here is about learning them how to do them across in a row. So you need to do them in a row in this case. And then we have in our third example, we actually have another trinomial and a binomial. And you can just you can put them in that same order they have it, and you go across. X squared, negative 5x, positive 25, and you can see, regardless of how many you have on each side, you just have to make sure you multiply every single one, and then just simply add them all up. Okay, so that's the end of lesson number 5.